The third law in this unit is called the combined gas law, and you might expect it to be a combination of the two that we've already looked at, and you would be right. So Boyle's law, which relates pressure and volume, and Charles' law, which relates volume and temperature, can be combined mathematically to give us one combined gas law that relates all three of those variables. So from Boyle's law, we know that pressure and volume are inversely proportional, so P1 times V1, and that's equal to P2 times V2. From Charles' law, we know that volume and temperature are directly related, so we usually divide. So V1 over top of T1 and V2 over top of T2. So the combined gas law puts together pressure, volume, and temperature all together, and that gives us P1 times V1 over T1 is equal to P2 times V2 over T2. Just like before, pressure and volume units must match each other within the question. So if you have kilopascals for one pressure and you've got millimeters of mercury for the other, one of them has to be converted. Temperature, again, must be in kelvins. We always have to work on the absolute value or absolute temperature scale. And again, amount or moles of gas must remain constant. So our last variable, moles, has to stay the same for us to use this combined gas law. So let's do one example looking at all of those different variables together. A 5-liter balloon of oxygen gas is filled on the beach where the temperature is 28.5 degrees Celsius and the atmospheric pressure is 100.34 kilopascals. Let's label all of those variables. So 5 liters is V1. The temperature, 28.5 degrees Celsius, is T1. We're in Celsius. We know we're going to have to convert that into kelvins. And the atmospheric pressure of 100.34 kilopascals is now P1. If the balloon is taken underwater on a dive, where the temperature of the water is 25.2 degrees Celsius, there's T2, and the water pressure is 157.25 kilopascals, there's P2. What is the volume of the balloon? We're looking for volume, so that's our unknown. We're looking for V2. So let's start looking at our formula and rearranging to solve for V2. If we take our combined gas law with P1 V1 over top of T1 and set that equal to P2 V2 and T2, we want to rearrange and solve for V2, this one. So we need to move the pressure 2 and temperature 2 to the other side. So when we rearrange, we're going to multiply by T2 on both sides, and we're going to divide by P2 on both sides. So our new formula, once we rearrange to solve for V2, is going to look like P1 V1 times T2, all on the top, over top of P2 and T1. So now in our formula we can start substituting in and doing our conversions for our temperature. So pressure 1 was 100.34 kilopascals. Volume 1, our starting volume, is 5 liters. And temperature 2 is 25.2 degrees Celsius. We know we have to change that into Kelvin, so add 273.15. Then on the bottom, we have P2, that's 157.25 kilopascals, and temperature 1 of 28.5 degrees Celsius. Again, we have to convert that, so add 273.15 to give us our Kelvin temperature. Make sure you do those temperature calculations first. The top one should come out to 298.35 Kelvin. And your second temperature, or T1 that's on the bottom, will be 301.65 Kelvin. So make sure you use those values in your calculation. Final answer with 3 significant digits is 3.16 liters. And there's the combined gas law.